Tahir Naeem and we are studying Management Information System. So far we have covered 16 lecture and today is our lecture 17. In this lecture we will study the benefits of a good system design. So in this system we will discuss the flow chart and also we will discuss what we will achieve by designing a good system. The outline of our today lecture. First of all, we will discuss the benefits of good system design. Then we will discuss the system analysis and design methods. Then we will discuss structure analysis and design. Then we will discuss the flow chart. Then we will discuss the good practices which must be followed in the designing of the flow chart. Then we will discuss the symbols. First of all, we will discuss the benefits of good system design. Better understanding by the developer of the system. A properly designed system helps in elaborating and understanding the refined aspects of the system. So whenever we design a best system, it will help in understanding by the developer. So if we design a good system, then developer will have an easy time for coding the system and executing the system. A properly designed systems will be elaborate and helpful, and user will be the IT professional will be able to grasp the whole system. System development become efficient in error-free design. System saves development time since it helps in understanding without discussion. So if we have designed a good system, it will be a very efficient system. It will not require any tweaking if there is any so a good system design is generally free of any errors, and if it is free of any errors, then it will be able to save the cost and time of tweaking the system. A well-designed system also helps in early detection of the problem in critical areas. So whenever if there are problems in the business plan, a business process, if we design a good system, we will be able to pick up these errors or inefficient system, and we will be able to rectify it. Better quality of reporting formats. Modification can be made easily in the system. So if we design a good system, then we will be able to achieve a good report. So modification can if you want to alter these reporting formats, then we will be able to alter the system easily. Little maintenance is required in the operations phase. So if there is a good system design, then whenever the system is operational, then it will need a little maintenance. It will not require a huge amount of coding. So system analysis and design methods. Two approaches are followed for system analysis and design. So normally whenever we want to design a system, we normally follow one of the two approaches. So first approach is structure analysis and design. So it basically we have a preset of structure which we follow. So there are various tools in this structure analysis design, such as flow charting. So whenever we want to follow this, first of all we have to design a flow chart. Flow chart means that what is the business process of the whole system. Data flow diagram or DFT. So after flow charting, then we have to draw the how data run from the input to output. ERD, entity relationship diagram. So basically here we want to in this we establish the relationship between different entities inside the system. So basically in this we draw up different entities which are used in the system, and we link the entity into different component of the system, so the whole system become interdependent and we can access one part from the other easily. So the second is object oriented analysis and design. So thus in this we treat the system as an object, and we analyze this object and design the system accordingly. Structure analysis and design. Structure analysis and design follow a set of good practices in generally accepted standard. Proper documentation of the system is made by the following standard rule. So whenever we analyze and design a system structurally according to SOPs, we have to follow good practices established in the industry, and the general standard which is global, we have to follow the global standards, and we have to draw proper documentation of the whole system so that everybody can understand this documentation and how the developer have designed the system. So first of all, we will discuss flowchart. What is flowchart? A flowchart is schematic representation of a sequence of operation as a manufacturing process or a computer program. So basically, it's in flowchart basically how the operations are performed in a sequence in manufacturing process or a computer program. Like manufacturing process, if you want to manufacture something, then we procure raw material, then have process it, and then at the end we have the end product. So similarly, in the flow chart we have all the sequence of operation, what should be done, in what order should be done a computer program. So it is a schematic representation of the whole operations. So first of all, what is the flow chart? Flowchart is the most commonly used design and analysis technique. This diagrammatically presentation gives a quick understanding of the business process and flows. So basically, flowchart is a diagrammatic representation of the system analysis and design. The system we want to develop, first we must have to draw a diagram of the whole process and present it in a diagrammatic way so that everybody can understand the business process and flows of the data. Symbols. Although there are many symbol used proposed by various standard, but we would discuss some of the most commonly used symbols. Understanding symbol represent functions, flows, etc. may be more readily understood by those who have some knowledge of the symbol. From the technical or academic point of view, we have to know what symbol are used for various functions. So whenever we want to draw a flow chart, we use symbols for the, as we have discussed before, that we use our diagrammatic presentation. So whenever we want to draw a diagram, in diagram we have to use symbols, and these symbols are commonly used. So it's not like I'm using my own symbol and another person is using his own symbol. So it must be a common symbols used for the functions, flow, etc., which can be understood by any person having the knowledge of the symbols. So we have to know what symbols are used, so it is necessary that we understand the different meanings of the symbol so that we understand the flow chart. So here we are discussing the flow chart. First of all, arrow. So in a flow chart we are using arrow. So arrow, the usual direction of a flow of procedure or system is from left to right or top to bottom. So whenever we want to draw a diagram or flow chart of operation, so here arrow means that in which side the data is going. So it normally have to be from up to down or from left to right. So generally whenever we want to draw a diagram of flow chart, it must be from up to down or from left to right. It's a global accepted rule. Ensure that the flow chart has the logical start and finish. So we have to ensure that the flow chart must meet the logic of where it is from where it is starting and where it ends on. Terminator. As the name suggests, only one flow line is used in the conjunction with terminator or symbol. So whenever we want to draw a terminator, one line must be used. So generally the shape of terminator is like this. So whenever whenever we use in the flow chart, it must be like this. Process. Process is basically represent the manipulation of data. Only one flow line should be come out from the process symbol. So whenever a process is done, there is one result. Just I want to give you example. When you add two number 2 plus 3 5, so there is only one result coming out of this process. So there are different things which you want to manipulate, and and the result will be only one, and only one symbol or arrow must come out of it. It must not more than one symbol come out of the process. So there is another, and this is the normal symbol used to represent the process. So decision basically whenever a decision is to be made, this symbol is used for this for the representation of a decision. Only one flow line should enter a decision symbol, but 2 or 3 flow lines, one for each possible answer, should leave the decision symbol. So here so there is, as you can understand that if there is a decision to be made, if I am going forward at one point, I reach then there are 3 roads or 2 or 3 roads from onward. Then I have to decide from which road I have to follow. So it must be there are one decision must be made from the multiple decision. So here is the example that if I have given a number, if number is number and decision is to be made, what is this number? So there are 3 possibilities. So here it is equal to 0, then it will go there. So if it is less than 0, it will go there, and if it is greater than 0, it will go there. So there are 3 possible answers of given input in this process. So here, look at here, there is it's not mandatory that there must be a 3 choice available to us. There are many choices or 2 choices available to us. Look here, if we here a number is put into the decision process, and here we want to check if this decision is greater than less than 0, then it must go there, and if it is greater than 0, it must go there. If it is less than 0, it must go there. So this is the symbol used for the decision. Connectors. So as the name suggests, connector is basically used to connect for connection. Connectors, if the flow chart become complex, it is better to use connector symbol to reduce the number of flow lines, avoid the intersection of flow line if you want to make it more effective and better way of communication. Basically, whenever we want to use a connector, because a system, whenever we want to design a system, it's not always a simple system or very easy to explain the system. So if the system is complex, then there must be a number of flow lines. So if there are 2 or more than 2 flow lines, then we can connect these if there is intersection of the flow line, then it is connected by this connectors and this is the typical symbol used for connector. Predefined process. So predefined, as the name suggests, it is the process which is already defined or already defined in the system. This represents a named process consisting of one or more operation or program steps specified elsewhere. So basically this process, basically these are the processing takes place and it is specified somewhere else and this is the symbol used for the representing the predefined process. So here this is the symbol used for the single document, because it's not necessary. Normally whenever we want to design a system, it consists of more than one document, but if it consists of single document, then this symbol is used for a single document. One page connector. So whenever we want to draw a process, it is not generally it is more than one page. Normally it's like 4 or 5, it depends on the system, but it consists of many pages. So how this is the off page connector. Whenever this is the symbol used, that the next process is done on the next page. Use the connector remote flowchart portion in a different page. One flow line enters and exits. So here whenever we use off page connector, one line, let's suppose that's the end of the it's used as the end of the page, and here one flow come here into it, and whenever we want to start a new page, this we have to draw this off page connector, that it is continued from the previous page, and here the next steps are done. Input and output. So whenever we design a system, there must be input, and after the result there must be output. So this is the symbol used for input and output. Input and output is used whenever data is into the flow chart are displayed from the flow chart. A single flow line enters and a single line exits. So whenever data is entered into a flow chart, or it is displayed to the user, so this symbol is used for these processes. Input and output. Used whenever data is entered into a flow chart or displayed from the flow chart. A single flow line enters and a single line exits. So the main characteristic of the input output is that a single arrow must enter into it, and a single output, a single arrow must leave it, because whenever you done the operation, whenever you enter the input, this is forwarded for the further processing. Good practices. Like every methodology, flowchart also have a set of recommendation practice for flowchart. So basically good practices are those behavior or the norm or SOPs which must be followed, are recommended to be followed for designing a flowchart. And drawing a proper flowchart, all necessary steps that are part of the process should be listed out in a logical order. So whenever you want to draw a flow chart, there are different steps involved in it, and these must be in a logical order, and every user must understand the order. The flow chart should be clear, neat, and easy to follow. There should not be any room for ambiguity in understanding of the flow chart. So the basic purpose is that the flow chart let us understand the process clearly. So the flow chart must be clear, neat, and very simple to follow. It should not have the ambiguous system that we doesn't understand. It is useful to test the validity of flow chart. So basically whenever we draw a flow chart, we must test it. How we must test the validity of a flow chart? That we enter data, and we process the data, and if it is giving the correct result, then the flow chart is valid. So the flow chart must be valid. Advantages. So after whenever we draw a flow chart, there must be some advantages of flow chart. The benefits of flow charts are as follows. Communication. So basically the primary purpose of flow chart is communication. Flowchart are better ways of communicating the logic of the system to all concerned. Flowchart are more focused on decision making and activities relating there to take in the center of relevant process. So basically, flowchart is a form of communication. It helps us and every user to understand the logic of the system, how the system works, and what decision making process are involved, and what activities are taking place in the system. Proper documentation. After communication, it helps us into documentize the whole system. The program flowchart search is a global good program documentation which is needed for these purposes. So whenever we draw a flow chart, it is basically saved as documentation, because if any other developer or any person want to observe or want to understand the logic behind the system, how it is designed, it is basically a documentation of the program which is designed. So these are the two primary benefits of flowchart. So there is added advantages of flowchart. First of all, efficient coding. So whenever we draw a good flowchart, the flowchart acts as a guide or blueprint during system analysis and program development phase. So the flowchart is a basically blueprint or structure which must be followed by the system analysis and throughout the program development. So basically, flowcharts helps us in coding efficiently. Proper debugging. The flowcharts helps in locating and correcting errors, also called debugging. So debugging is basically all about correcting the errors if there are any errors in the program. So whenever we draw up the flowcharts, we were able to locate and correct errors in the document. Efficient program maintenance. After because the flowchart, if the benefit of flowchart doesn't end in the during the development of the program, but it is continued during the program. So if we want to maintain the operation of this program which is developed, so it's very easy to maintain the program if there is a flowchart available to us. These are the references from where I prepared my lecture. If you have any questions regarding today's lecture, feel free to email me. Thank you. Allah Hafiz.